fluid. And if you look at the flow of cerebrospinal fluid, you have to start from where it's formed. So it's formed within the ventricles of the brain and through the choroid plexus. So the choroid plexus is basically a mashup of many things. So you have the pia mater, we have capillaries, and then you also have ependymal cells which help to produce cerebrospinal fluid. And so the choroid plexus is usually found in very specific regions of the ventricles. So within the lateral ventricle, you usually find it within the body of the lateral ventricle and also on the inferior horn of the lateral ventricle. So it's usually found on the ventricular surface of the hippocampus in the inferior horn. And then you also have also in the third ventricle. So in the third ventricle, you tend to find it along the roof, and then you find it also on the roof of the fourth ventricle. And so these areas produce cerebrospinal fluid within the brain. Within the spinal cord, cerebrospinal fluid is usually formed by ependymal cells. And so these ependymal cells are very critical in formation of cerebrospinal fluid, and we consider them neuroglial cells. Now, once you form cerebrospinal fluid within the ventricles, so you have two paired lateral ventricles, right and the left, and so they exit via what we call the interventricular foramen of Monro and enter into the third ventricle. From there, they move, the fluid is moved all the way to the fourth ventricle via what we call the cerebral aqueduct. And so from there, you have the fluid going to the fourth ventricle. And within the fourth ventricle, it exits into what we call the cisterns. And so this exit into the cisterns, you have through two main foramina, Magendie and Luschka. So Magendie is the median foramina, and then the lateral foramina are the foramina of Luschka. And then within the cisterns, so the cistern is basically an enlarged subarachnoid space that has this CSF. And so it flows up to the level of the superior sagittal sinus where it's reabsorbed. And so basically that forms the flow of cerebrospinal fluid. Now there are many factors that increase its formation or reduce its formation. You'll tend to form more of the CSF when you're asleep. As you sleep, you tend to retain more of carbon dioxide, which tends to cause more vasodilation within the brain. And this tends to increase the ultrafiltration and increase the production of cerebrospinal fluid. And so the cerebrospinal fluid can be affected in many conditions clinically. We have congenital issues like aqueductal stenosis that gives us what we call an obstructed hydrocephalus. So hydrocephalus is where you have accumulation of CSF within the ventricles, which enlarges the head of the baby. And so there are mainly two types. We have communicating versus non-communicating in children. And then amongst the elderly, we usually have what we call another form known as ex vacuo, where there is atrophy of the brain, which increases the ventricular space. So what's the difference between communicating and non-communicating hydrocephalus? In communicating hydrocephalus, what you have is this movement of CSF, which is not impeded by anything, but there is too much production or too little reabsorption. So too much production could be something like tumor. Too little reabsorption could be something like a blockage of the arachnoid villi. So the arachnoid villi are responsible for reabsorption. Now, when you have non-communicating hydrocephalus, it means that the path that is taken by the CSF is blocked, for example, in aqueductal stenosis. So when you have obstructive hydrocephalus, usually you can put what we call a ventricular peritoneal shunt, and this can help to alleviate the blockage.